we'll start with position time graph. That is what position or distance along the y axis and time along the x axis. Suppose this is your origin and object is here. So it start moving in the positive x direction. After 1 second it will travel 10. After 2 seconds it will travel say 20. After 3 seconds it will travel 30. After 4 seconds it will travel 40. So these are the what positions, means distances from the origin. Okay. If I plot this in the graph, obviously we have plotted this in the last class. So now time I will take here 1 second, 2 second, 3 second, 4 second, 5 second. So here I will take it as 10, 20, 30, 40, 50, so on, like this is what distance, or we can take s or x, whatever. So time you can take along this axis, x axis. So when time is 1 second, displacement or distance is, remember we are in straight line motion, displacement is equal to what? Distance. Okay, this is the first point. 2 seconds it will come to 20, so 20 is here, so this is what 2 seconds. 30 for third second, this is what 3 seconds, so this is what another point. 40 for fourth second, so this is what. So these are the what the points we got for different time and distances from the mean position. Okay, so this is what one. So when we join this one, when time is 0, displacement is also 0 or distance is also 0. So object is at origin. So line start from here. And it will become a straight line. So what its straight line means? It's to understand what this straight line gives is we have to calculate its slope, or we have to find out its slope. So I will take slope over here. So this is what the slope A, B, C. So slope is equals to AB divided by BC. So what is AB? AB is, this is what AB, 40 minus 20. 40 minus 20. From here to here it is 40. Here to here it is 20. So 40 minus 20 divided by time. 4 minus 2. This is BC. 4 minus 2. So 4 minus 2. So what we will get? So 40 minus 20 is 20. 4 minus 2 is 2. So we will get as 10. So here this is what distance means, meter divided by time in second, so meter per second. So this slope is nothing but velocity. So V is positive. You are not getting any negative value. So V is positive. That means what? That means object is started from the origin and moving in the direction of x axis. Okay, so object moving along positive x axis, that is very important. So positive, if your slope is coming positive, means velocity is positive, means it is moving in the direction of positive x axis. Okay, so we'll think what will happen if this slope comes negative. Okay, so suppose there is a origin, and so this is what the I will take some instance of time. Here it is 50. Remember, at time t equals to 0, object is already at 50. This is what initial position. So suppose you are having the car. This is what I will take it as 50. Suppose you are having the car. So now it has to travel. It will come to 40. So it will come to 30. It will come to 20. It will come to what? 10. It will come to 0. That means car is going in this direction. So if I plot the graph now, this is what t equals to 0. T equals to 1, 2, 3, 4, 5 seconds like that. So if I plot the graph, no need to change anything in the graph. In the graph I will take as it is. This is what 1, 2, 3, 4, 5. So here 10, 20, 30, 40, 50. Okay. So now when t equals to 0, this is what origin, t equals to 0 here. When t equals to 0, already object is at 50 meter distance. So already object is at 50 meter distance. This is what your initial position. So when t equals to 1 second, object comes to 40. Object comes to 40 means somewhere here. So object is coming to 40. Okay. So this is what. Then time t equals to 2 seconds, coming to 30. So coming to 30 for 2 seconds. Okay. So this is what. So next point, for 3 seconds, 20. 3 seconds it is coming to 20. Okay. So for 4th second it is coming to 10. For 4th second it is coming to 10. For 5th second it is coming to 0. Okay. So this is what going to be your graph. Again it is a straight line. Straight line means what? Straight line means it is moving with the uniform velocity. Velocity is not changing. That means you can take slope anywhere. You can take slope anywhere. You will get the same value. Either you can take here or here or here. You will get value 10 meter per second only. That means velocity is uniform anywhere in the motion. Okay. So now it is coming in this direction. So what you understood is, you understood that velocity is uniform, or it is moving with a constant velocity. One more thing what you understood is, initially object is not at origin. Initially when t equals to 0, object is not at origin. Where it is at 50 meter distance from the origin. Okay. So now what we'll do is, we know velocity is constant, but what is the value of velocity? So to calculate the value of velocity, what you have to calculate? You have to calculate the slope. So we'll see what will slope is very important. So slope is equals to what? AB divided by BC. Okay. So now better if I write in terms of x2 minus x1 by t2 minus t1. x2 minus x1 divided by t2 minus t1, or s2 minus s1 divided by, what is that? This distance minus this distance. You can take s2 minus s1 or d2 minus d1, whatever. So now we will see what is t2. t1 is 1 second here. t2 is 3 seconds. Okay. So t2 is equals to 3, t1 is equals to 1. t2 means x2. This is what your x1. Don't think that larger one is x2. When time is t1 is here, this will become your x1. t2 is here means this will become your x2. So x2 minus x1. x2 is what? 20. x2 is 20 minus, what is x1? x1 is 40. Okay. So now minus 20 by 2. So what you will get? You will get minus 10 meter per second. So slope is what? Velocity. So now we are getting velocity as negative because car is moving in opposite direction. It is along negative x axis. So negative sign indicates that. So object moving along negative x axis, or opposite to the initial one. Before it was moving in this direction, you are getting slope as positive. Here it is moving in opposite direction, so you are getting negative slope. Okay, so negative slope and positive slope, what they will indicate? Slope will always indicate not only velocity, direction of motion also. Okay, so that is why slope is very important. Slope will give the magnitude of velocity and also direction of motion. Okay, so this is how we can calculate the negative slope and positive slope. We will take one better example. So this is what your origin. From the origin, a car started moving. Okay, so a car started moving in this direction. So 1 second, 2 second, 3 second, 4 second, 5 second. So car comes here. Okay, so now what will happen? It will apply the brake, means it will come to stop and it will return and it start moving in this direction now. Okay, this is what direction. Okay, so before it was here, now it is moving in this direction. So time 1 second, 2 second, 3 second, 4 second, 5 second. Again from 5 it will start, 6th second. 5 second it will go to the top, then 6th second it is coming back. Okay, so here it was 10, 20, 30, 40, 50. Here it is 50. Okay, so now it is coming back. Time to will keep on changing only. So 5th second, then it will become 6th second, then it will become 7th second, 8th second, 9th second, 10th second. Okay, so this is what the motion. Okay, now if I plot the graph for this one, so what I will get? So 1 second, we need more time. So 1 second, 2 second, 3 second, 4 second, 5 second, 6 second, 7, 8, 9 and 10. Okay, so on this side not much required. So 10, 20, 30, 40, 50, 60, 70, so on like that. Okay, so this is what 1 second, 2 second, 3, 4, 5, 6, 7, 8, 9, 10. If I plot the graph now for this motion, or they may give the graph, they may ask you what is the type of motion, or they ask you to describe the motion. Okay, so from the origin, when time is 1 second, when time is 0, object is at 0, no problem. When time is 1 second, object is at what? Object is at 10. So object is at 10. Okay, so this is what the position of object. Okay, so next, when t equals to 2 seconds, object is at 20. So object is at 20. When time is 3 seconds, object is at 30. So this is what 30. Then 4th second, object is at 40. Then 5th second, object is at 50. Okay, so these are the points which we got. Now this is what 50 when time is 5 seconds. 50 when time is 5 seconds. Now car stops, take reverse, coming back. When time is 6 second, this distance from the origin is how much? Distance from the origin is 40. When time is 6 seconds, so again it comes to what? It comes to what? 40 only. Okay, so this is what? 40. When time is 7, so it is coming to, when time is 7 it is coming to 30, so it will come. Okay, so when time is 8 second, 20. When time is 8 second, it is coming to what? 20. When time is 9 second, it is coming to 10. When time is 10 seconds it is coming to 0. Okay, so these are the what next set of points. Okay, so this is what the motion of the object which we can graphically represent. It starts from here. Okay, so this is one passing through origin. So next is this is what product. Okay, so now this graph will indicate you what? This graph will tell you the everything about the motion. Okay, so now here it is going. When time is 0, it is at origin. When time is 10, again it will come back to origin only. When time is 10, again it will come back to origin only. That is why you are getting the final point also origin only. Initially it was at origin only. It will move till 50 meters. So it will move till 50 meters. After 50, return. So again coming back. So what we can expect here is, till here we have to expect positive slope, positive velocity. From here, velocity should be what? Slope should be what? Negative, because reverse direction. So if you take a slope over here, so if I take slope here, so this slope will give what? Slope 1. What it will give? T2, what is that? X2 minus X1. So 40 minus 20. 40 minus 20. So 40 minus 20 divided by 4 minus 2. 4 minus 2. What you will get? This is what 20 by 2 means 10 meter per second positive. Similarly, if I calculate slope on this side, so slope is equals to x2. x2 is what? This is what your x2. x2 is what? 20. 20 minus 40 divided by this one, 8 minus 6. 8 minus 6. So this will become what? Minus 20 by 2. Minus 20 by 2 means what? Negative 10 meter per second. So velocity is negative here, velocity is positive here. Again, why you know? It is coming till positive x direction. Here it is going again negative x direction. So here, while going in this direction, velocity is what? Plus 10 meter per second. While coming back, velocity is what? Minus 10 meter per second. Now, what is velocity here? Velocity at fifth. What is the velocity here? If you want to take a slope, it is very small. You cannot take the slope over here. Here, if you consider this point, slope is going to be what? Slope is going to be 0. That means velocity at this point is going to be 0. Obviously, because when you come to fifth, what you will do? You will stop your car, or your car comes to rest, then take the U-turn, then you can come. So at this point, velocity is what going to be almost 0. Okay, so that is why we will not get the slope over here. So here velocity is going to be what? 0. It is just like throwing a stone. So stone go with a high velocity, here velocity will become 0, and it will come back. It is just like that. It is just like that. Okay. So from this graph, what we can understand? We can understand everything about the what? About the motion of the object. Okay. So this is what going to be your graph. This is what going to be your graph. Okay. So they will give this kind of graph, and they will ask you to describe the motion. So now if I take a tricky question, how they can make questions tricky. Okay, so suppose you are having the position along this direction and T along this direction. So body A is moving here and B is moving here. Okay, body A is moving in. This is a graph of body A and this is the graph of body B. Now what they are asking is velocity of A is greater or velocity of B is greater. Okay. So suppose if they ask velocity of A is greater than velocity of B, or velocity of A is less than velocity of B, velocity of A is equals to velocity of B, D, velocity or none of these. Okay, none of these. Okay, if something comes like this, how we can get the velocity of A and B? You may say, sir, we will take this slope. We will take slope over here. So which slope is greater? that is going to be greater velocity. If slope of A is greater, then velocity of A is what? Greater. Okay. If slope of B is greater, velocity of B is greater. That is fine. That is fine. That you can obtain you can calculate the slope if and only if they give the values over here. They should give the values here. But value is not given only. Value is not given only. Then how you can calculate slope? Remember, without calculating the slope, we cannot decide anything about the velocity. Getting the point? Without calculating the slope, we cannot get anything about the velocity. Okay. Now, slope, to calculate the slope, we don't have the proper data. Then how we can calculate the slope? We have another idea for the slope. What is that? Slope is equals to tan theta. Have you remembered this one? Slope is also equals to tan theta. What is theta here? Theta is angle with x-axis, angle made by the curve with x-axis. That means this is what? This is what the angle. This is what of B and this is what of A. This is angle of A and this is angle of B from here to here. From x-axis. This is what x-axis. Okay. Now, angle of B is greater or angle of A is greater? Obviously, angle of B is greater. That means theta B is greater than theta A. Theta B is greater than theta A. Okay. So, theta B is greater than theta A. If theta B is greater than theta A, tan theta B is greater than tan theta A. Now I will plot some graphs. We have to describe the motion. Okay. So first one, obviously it is the position time graph. Xt. Okay. Distance and time. Okay. So first graph is like this. Second graph is xt is like somehow something starting from here. So third graph I will draw like this. So this is what the third graph I am drawing like this. So same xt. So fourth graph I am drawing like this. This is what xt. Okay. So graph is going like this. So now we have to explain the graphs or that motion. What is the we have to describe the motion. Okay. So how we can describe the motion now? See, first one, nothing is given, no distance, nothing. This is what the distance from the origin. This is what the distance from the origin. When time is 1 second, distance is what, say some 50. When time is 2 seconds, distance is again 50. When time is 3 seconds, distance is again 50. That means this is what your origin, object is at 50. When time is 1 second, 2 seconds, 3 seconds, object is there only. Object is there only. That means what? Object is not moving. That means what? Object is at rest. Object is at rest. So from this position time graph, what we got is, we came to know that this object is at rest. Okay. So next, if we see here, already it is at some distance. Say this you can take as some 20. So time t equals to 0 here. When time become 1 second, it is coming here. Time become 2 seconds, it is coming here. Time become 3 seconds, it is coming here. Means it is moving. So if you look at the origin is here, object is already at 20. When t equals to 0. Object is already at 20 when t equals to 0. That means this much distance it already crossed. Okay. So now it is what? 1 second it will come to 30, 2 seconds it will come to 40, 3 seconds it will come to 50, so on like that. Okay. So what we got from this graph? If you calculate the slope, you will get the slope. That is what the velocity, and velocity is same everywhere. Velocity is going to be same because straight line. Whenever graph is straight line, velocity is same everywhere. Means slope is same everywhere. So what we can conclude here? Object initially at t equals to 0 is at 20 meter from origin. Object initially when t equals to 0 is at 20 meter from origin. After that, what will happen? It start moving from here. It start moving in positive x direction with uniform velocity. Okay, so then it start moving with uniform velocity along positive x axis, because you will get the slope as what? You will get the slope as positive. So slope is positive here. That means what? Velocity is positive. Velocity is positive. Remember. So next here when t equals to 0, already object is say at 100. So this is what your origin. Already object is here at 100 when t equals to 0. After that, when you calculate the slope is coming to what? Negative. Means velocity is what? Velocity is negative. Velocity is negative means it is moving in this direction, means along negative x axis or towards the origin. Okay, so initially object is at 100 meter from origin or reference point. Then again, what? Velocity is uniform, velocity is same everywhere, but it is negative. Okay, so object moves with uniform velocity along negative x axis means opposite direction. Okay, so if I come to this graph, so here what is happening? Slope is positive only, no problem. Slope is positive, and when t equals to 0, object is here only at origin. But slope is not same. Slope is not equal everywhere. Slope is different. So velocity is what? Velocity is variable. Velocity is variable. In fact, velocity is what? Increasing. Velocity is increasing. Okay, here its slope is what? More. So here it is less. So as denominator go on decreasing, slope is this divided by this one, this by this one. What is numerator is go on increasing, denominator is go on decreasing. That means slope will what? Slope will go on increasing. So slope is what? Slope is increasing. Getting? So if slope is increasing, obviously what? Velocity is increasing. Velocity is increasing means what? So it is moving with a variable velocity and it is increasing starting from what? Starting from the origin. Okay. So this is how we can describe the graphs. Okay. So if I take another example, suppose instead of doing this graph like this, if I make a graph like this, so now what will happen? When time is 2 seconds, it is here. When time is 2 seconds, then also you are saying it is here. Is it possible to come from here to, from origin to some 18 without changing the time? If you want to move, time is required. Without taking time, can you move from here to some distance? It is not possible. So whenever distance comes, to travel some distance, time is required. But here time is not changing, only distance is changing. This is highly impossible. That means this graph is not valid. This graph is not valid. Okay. So like that we have to describe